Hello developers, let's start developing. My name is Veko and today we're gonna focus on the 25th day of the 2022 Advent of Code. This is the last day, so we are finally there and the map is complete. I haven't solved all of the tasks. I should have 48 stars by now, but I only have 34. We'll fix that uh, eventually. But you can see it is the 25th of Yeah, you can see now. It is the 25th of December, so today was the last task was open. So let's see what's happening and how it's happening. And I think that for a change, we got an actual easy task that we will be able to solve in a very short time frame. So we have some balloons and each balloon has some number that identifies how much fuel it needs. Only it's not done in the decade numbering, decimal numbering system. That means where the first number is a digit from 0 to 9 that says how many times we need to multiply 10 and so on and so forth. No, this is in a special pentanic, pentary or something like that numerical system. So the numerical system has 5 different digits, and those 5 different digits are not as you would expect 0, 1, 2, 3, 4. No, it is quite different. It's actually a centered pentary system. So the middle digit is 0, and then we have 1, 2, and -1 and -2. So we can, with a single digit, we're not gonna display a number from 0 to 4. No, we're gonna show a number from -2 to 2. So how do we display 0? We display it like this, 1 we display it like this, 2 we display like this, -1 is a single minus, and -2 is what the task calls double minus. This thing. So this is -2, this is -1. So if we have something that's, let's say, 1 double -2, this means that on the zeroth base, we have 2 units. On the 5 places, we have -2 units. And on the 25 places, we have 1 unit of that. So this number will be 25 plus -2 times 5 plus 2. So this number is 25 minus 10 plus 2. That's 17. And with this is enough that we can display all the numbers that we need. And this is complete. Each number has a unique representation, and each representation displays a unique number. And our task is basically just to display this. And this numbering system is called Special Number Analog Fuel Units, or SNAFU for short. If you don't know what the SNAFU usually stands for, please Google it. It means when something is designed specifically in such a way that is as weird as possible. So, the first task that we need to do, we just need to add all our SNAFU numbers together. And we have quite a lot of them. And when we do that, we need to transfer it from a decimal number to a SNAFU number. So we basically need to implement 2 functions. We need to have a pentary to decimal, because I'm not going to implement addition in this weird pentary thing. One way to do it would be to work directly in the pentary system, because we can see what the rules for addition and rules for subtraction is. We can do that. But let's not do that, because I know about addition and everything in the decimal system quite well. So I'm just gonna do a transform. So I will take the initial number, transform them to decimal, do all the calculation, all the calculation, meaning sum them up in decimal, and then from decimal I'm going back to pentary. So for pentary we have an input that's a string, and we're gonna return a decimal number, or as it's known in JavaScript, number. Let's just say it's 0 for now, and we're gonna have another method that says we're gonna give you a decimal number and transform it into pentary. As far as the input goes, we're just gonna read the number. Read each line into a number. And after that, I will just say, well, what is the total? The total is get all the input line numbers and map them from a value, let's say, to a pentary to decimal value, and then I have a sum method that does exactly that, and I will sum them up. But first, I will want to see them. Let's see what this does. So this is gonna give me just a bunch of zeros because I said move them to 0. So let's implement. How do we transform a string from a decimal to a pentary? From a pentary to a decimal. Yeah, let's keep the return 0 so we can do some things. So first of all, I will need to get the digits. To get the digits, I will split them on every position. So means that for this one, for example, I'm getting 4 elements, 2, minus 2, 0, 1. And now I will need to reverse them. Yeah, so they have the indexes. The indexes are not 3, 0, 1, 2, 3, but the indexes are 0, 1, 2, 3. Because we will need to multiply this with 5 to the 0 degree, 5 to the first degree, 5 to the second degree, and 5 to the third degree. So I will just put in a reverse here. And then we can map this. And we're gonna map. So each digit and each index is gonna get transformed into, oh, we have a situation. You cannot really multiply this sign because this is usually equals, it's not minus 2. So let's add a map. And so if we have a 0, it's 0. If we have a 1, it's 1. If we have a 2, it's 2. And if we have a minus, that is actually minus 1. And if we have a double minus, that's actually minus 2. So we're gonna add another map here. When we just take the digits, we can even do this before the reverse. Yeah, let's do that. And yeah, let's do it this way so it's cleaner. We're not returning anything. We're gonna do a map of each digit to the corresponding digit map. So now we have numbers. And then we're gonna reverse them. And then we will map each digit, and digit is right now a number actually. This is a string array, digit map. No, this is not an any array. So yeah, we can say that this is explicitly a record mapping from a string to a number. And now it will know that we are returning an array of number, because previously this was a constant, but we never guaranteed that all the values will be number and these numbers, and now we do. So right now digit will actually be a number, and we have an index that's also a number. We can raise 5 to the index power, and then we just need to multiply it by digit. And let's just log this. To see if whatever we're doing actually makes sense. Do we have an error? No. Yeah, we have this. So we have, for example, this 2, 10, 25. That means we have 2, 2, 1. And that does this number, 2, 2, 1. Let's do it on the first example when we have 6 digits. So we have 2, that's 2. We have minus 5, which is the minus. We have 0, which is a 0. A 0 is always 0, so minus 225. Yep. Double minus. This is minus 1250 because this is twice 625, which is 5 to the 4th. And then we have 1, which is this one, which is 5 to the 5th. Yeah, seems like everything is okay. So what happens if we just sum these up? We will get a number, and we just need to return that number. And I will transform this into a one-liner. So we're taking the input, we are splitting it, mapping the digits to corresponding numbers, reversing them, transforming them to the actual value, and summing them up. So now we should get something that is not all zeros. We should get some numbers, and let's see: 1747, 906, 198, 11, 201, 31, 1257, 32, 353, 107, 73, and 387. Seems about right. So now that we have these, we can just say, well, sum them up. What is the sum? It should be 4890, which I don't doubt for a second because seems about normal. So let's take the big input that we have. I have one concern. Maybe we will go over, because I see some numbers that are quite large. This one, for example, that might go over the maximum safe integer of JavaScript, because JavaScript works well with integers up to a point. And we're getting quite a big number. So this number is, let's see, it's that many millions, which means that many billions, so 32 trillions or something like that. And let's ask JavaScript until which number you're quite actually working correct. I've seen that constant a bunch of times, but I never seem to remember it. Copy the number. Let's see. That is this many millions, this many billions. Yeah, we're safe. Seems that we're off about 2 orders of magnitude. So we should be fine. So up to this point, JavaScript will calculate every integer operation, guarantees that each integer operation that has a result smaller than this will result in the correct value. Above this, not so much. It may happen, it may not, there's just no guarantee. So now we have our total number, and we just need to return the total number, but in a pentary kind of way. For now, we will just return a zero string, which is not gonna be the correct answer. Let's go back to the small input, because for that we know what the solution should be. We know that the solution should be 2 equals minus 1 equals 0. Let's see how we do that. Well, in order to transform a number from decimal to something else, we need to do a procedure, so to say. So we're going to keep dividing it with the other base, with 5, taking the remainder and decreasing the number. And that is going to give us one by one. So let's do this manually in a regular number 5 system. Transform this to a pentary, but pentary that is 0, 1, 2, 3, 4. How do we do that? Well, first of all, we're going to see what the remainder is when we divide it by 5. It's obvious that the remainder is 0. So we're writing out down 0 and dividing this number by 0. If we divide this by 5, we are getting 978, and we have a 0. If you divide this by 5, you will get a remainder of 3. So if we divide this, if we subtract those 3 and divide this by 5, we are getting 195. This has a remainder of 0 once more, and if we divide this by 5, we have a 39, and 39 has a remainder of 4. And if we divide 35 by 5, you get 7. And 7 has a remainder of 2. And if we divide 7 minus 2, that's 5. With 5, we have a remainder of 1. We have we have a result of 1. Yes, and 1 basically has a remainder of 1 and a result of 0. So once we get to 0, this is the number. So in pentary number, in a pentary number system, this number 4890 is actually 1240030. Why? Let's try the other way around. If we multiply this by 5 and this by 25, this is 75, and this by 125, and this by 625. Yeah, this is obviously 0, and this is, we're going to ask the calculator, and this is 625 times 4, 250. Yeah, that was to be expected. And I think I made a mistake. I don't think I need this one. I think it's just this, because we have twice 625 times 5. No, the 1 is correct. The 2 is wrong, I guess. Okay, manually this gets tedious. I don't think I made quite a good calculation. Let's maybe ask Wolfram Alpha. So we have concurrent entity base 5. Will it know how to do this? Yeah. It's this 124410 for 890. One two four 10. Ah, who knew? I actually had it correct. Only I messed up somewhere in this calculation. 12413030. Cool. Uh, so we're gonna do this thing, but we're not gonna do exactly that because that is gonna be wrong. Because we don't have this number, the 3, and we don't have the 4. We only have 0, 1, 2, minus 1, minus 2. So we're gonna say, well, first of all, there is one guard case that if our input is 0, then we have a special value. Otherwise, while the input is not 0, actually I'm gonna call this value. Sounds kind of better. Until the value is different with 0. We're gonna get its remainder. No. We're gonna get its remainder when divided by 5. And what do we do? Well, if the remainder is one of the ones that we are using normally, that's 0, 1, and 2. If that includes our digit, then we're going about this the normal way. Yeah, we're getting the new value, we're changing the value, just dividing it by 5. And this is actually wrong. So the correct way to do it is to do this. But since you've previously used the floor operator, that is exactly the same, has the same meaning. Because if we do take the floor, everything that this digit does will be chopped off. So these two expressions, the one that Copilot suggested and the one I wrote, will always have the same result. I just want to write it like this for reasons that will be obvious in a second. And then, well, we need somewhere to put the results. And that's going to be an array. And if we have a digit, we're just going to push our new digit, but we're not going to push it in the back, we're going to push it in the front. So each time we're pushing from the front so that we don't have to do the reverse operation. So we won't get it this way, we will get it the right way up. So instead of push, I'm going to say unshift. That's the reverse push. If the remainder is 0 or 1 or 2. Otherwise, if the remainder will never be minus 1 unless we're working with negative numbers, and we're not, we're gonna need to do this. So, yeah, not this, but something very similar. Now we will need to change the value. We will need to remove the remainder that we're gonna push from our value. And the remainder, the digit that we're gonna push, is actually, so we're not going to push this, we're going to push this because our digits are now strings. So we're going to push the double negation digit, and that's minus 2, and we're going to add this to the value. So we are still removing the value that we already took out. This means we're taking that digit from our value. So here, if it's 0 or 1 or 2, we're removing it. And if it's minus 1 or minus 2, we're still removing it, but removing minus 2 from something means that we're actually adding 2 to something. And the condition is totally irrelevant, because if the digit that can only be 0, 1, 2, 3, and 4, it's not 0, 1, 2, and it's not 3, it's gonna be 4, but let's just add it. And I always like to do this as well. If you know that this part of the code should never be reached, make sure that it is never reached. So if I ever reach an unreachable part of the code, according to my thinking, I will throw an error. So if that digit is 4, we are gonna add 1, and we're gonna unshift a minus. And at the very end, we're just joining everything together and returning it. And let's see if for our small input, we are getting some kind of a sensible result. No, we got this, that something happened that was never supposed to happen. Value digit 0 for value 978. First of all, if it's 0, it should be here. Let's debug it. Oh. This should be in the general else. Or alternatively, as I like the other way better, I will just add continuous for everyone. So this means that this branch ends here, this branch ends here, this branch ends here. Don't evaluate anything else. Yep, we had this response, and this response is exactly what we had here. So for our small example, we are totally correct. Let's see what happens when we add the huge real input, 127 numbers. It's gonna say, yeah, looks about right. I have no idea if this is right or not. I'm not gonna calculate it, as this is some huge humongous number actually. And that's the right answer. So this means that since traditionally task 25 only has a single part, because you can see that a very young elf already has a single star fruit that he can put inside the blender that needs 50 star fruits to function. We only need to find 49 other stars. That's 2 stars for each of the first 24 days and just 1 for the 25th day. Unfortunately, I don't have enough stars. I need 14 more, which means that I have 7 more days that I need to finish. And when I will, then we can start the blender. Still not, but we will get there. So don't forget to like and subscribe, and thank you for watching.